Off in the corner, like you don't know who I am by now, but anyway, I need to make these shorter. All right, I think I'm making them way today. We basically only have three big ideas to cover. All right, but I'm going to try and start making these much shorter, and actually adding a little bit of lecture, maybe 10 to 15 minutes of lecture during class when it's appropriate or something like that, so that we can kind of. I'm not spending every minute outside of taking longer than I thought they would. But anyway, so I'm going to try and keep each one of the. So I've wasted 2 minutes already, but I'm going to try and keep each one of these between 4 to 6 minutes long, which was my original intent, and we'll take it from there. Now today, what we're going to do is learn about how the resistance in an object is heat, temperature. In other words, the hotter something gets, that's why the coils in an oven. That's what they are. And so, and then we'll look at power. What power is, which is energy per second, right? Joules per second. But we'll look at it as a form of electricity. Without further ado, let's go ahead and get fire up these slides here real quick. Do the slideshow, everybody's favorite. Okay, different. So notice resistivity of copper, 1.7 times 10 to the negative 8. All right. Aluminum's a little bit higher, but aluminum has a higher resistivity, so it doesn't work as well. Silver, 1.59, a little bit better resistivity. Platinum is kind of high, nickel's kind of high. So silver would be a great conductor, but it's too expensive. But notice what happens when they also have different temperature conductivities. Okay, so as they get hotter, the temperature goes up. And here it is. For many materials, the temperature dependence of the resistivity is approximately linear. All right. In other words, the new resistivity is equal to the initial at 20 degrees Celsius resistivity times 1 plus the coefficient of the temperature coefficient of resistivity, and some values of alpha are listed in the table on the previous page. Okay, some materials exhibit, now this is what's cool. Some materials exhibit superconductor properties, and their resistivity drops abruptly to zero at very low temperatures. And they have a number of unique properties. They are impractical for everyday home use, however, because they must be cooled to cryogenic temperatures like 173 kelvins or something like that, or 100 kelvins. Those are what is known as high temperature superconductors. Most of them are down around 40 to 50 kelvins. Those types of things. In fact, I'm probably going to add a little thing on let you see a little video on superconductors here before I leave. Note to self, superconductors videos. There's some cool ones out there. So let's look at a problem, okay, before we get to electrical power, of maybe one of your homework problems. Did I give you a resistivity in your homework problems? I hope so. Now I'm wasting your time again doing this stuff. What's this guy? He looks like a resistivity problem. Looks like some of you've tried it and actually pulled it off. Difficulty 3, 7 minutes. Standard view. Don't want that solution view. Get that solution view out of here. You're making me mad. Okay, an electric water heater. No, this is again with that's with power. We'll take a look at that probably in class. Well, that was dumb. I didn't give you one of those problems. This one doesn't look like too many people have attacked this one, so we'll see. I'm wasting all your time. Sorry about that. What does this say? When a resistor is connected to an 11-volt source, it draws the same connected draw. Well, that's dumb. All right. Waste enough of your time. I will find it and come